Hello, my name is Alexander Lee, and my partner on this project is Melissa Lee. I would like to present our project titled Measuring Fall Risk Using the Internet of Things Automatic Chair. Here's our abstract. And the problem we're trying to solve here is that falls are extremely dangerous in older adults, and it's also extremely expensive. Two common tests used to assess fall risk are the 30-second chair stand test and the 5-time sit-to-stand test, which office staff manually test patients with. However, these measurements are both labor-intensive and provide limited data. There have been existing medical devices created for these tests, but they were either required external devices or they're too cumbersome for patients to perform. And so for our hypothesis, we believe we could create an IoT chair that was both low cost and could record both of these tests automatically and less labor intensively without any of the previous studies' limitations, while also collecting additional data. And so for the materials we use a standard chair, 4 pairs of weight sensors, 4 HX1111s, an ESP32 microcontroller, and various different coding languages. And so for our procedure, we mounted each weight sensor to a corresponding leg and connected the weight sensors to the HX711 and then to the microcontroller. The microcontroller then sends that information to our server, which can display the data on our website that we created. And so for our procedure, the clinical trials that we used to test our device included all adults aged 18 years old and older who met certain prerequisites. They were given a questionnaire and we measured their vital signs. Afterwards, we gave them instructions about the 30-second and 5-time tests, and we had them perform the 2 tests on our IoT chair while we visually measured the performing it in order to compare the results between the IoT chair and the manual test.
The results of our clinical study was that 102 participants were recruited. However, not everybody was able to complete the 2 tests. Our IoT chair was able to automatically record the data. On the left is a graph showing the IoT chair automatically recording the 30-second test and the 5-time test. On the right is an example of the IoT chair automatically recording the weight change. The purple line is the total weight change, while the rest of the colors correspond to each chair leg and its weight change. This slide is an example of showing that the IoT chair is just as accurate as a traditional observer method. This box plot shows that the 50% quartile range is overlapping the other quartile range, therefore they're not statistically different, meaning that the IoT chair is just as accurate as a traditional observer. This is the same for the 5-time test. The observer and the IoT method produce similar results. However, the IoT chair has more advantages. For example, it's automatic and reliable, is less labor intensive, is a low cost to produce, and easy compared to other studies. Additionally, the IoT chair has more data collection as it shows the weight on each chair leg and sit-stand interval for each cycle. This additionally improves the doctor's ability to determine fall risk, which means fewer falls and decreased mortality. In conclusion, we created an IoT chair that was able to be as accurate as a traditional observer method. However, it's easier to use and gives additional data for the doctor to better determine fall risk. These are a few examples of our future works. We want to display the number of repetitions performed in the 30-second chair stand test and the amount of time it took on the 5-time test. We also want to refine the device to be suitable for widespread clinical use. This is our reference cited. Thank you for listening to our presentation.